Hi, this is going to be a continuation of the demo for the flow path tool within Triangle 5. In this demo, I'm going to show how from the beginning to generate a simple flow path, capture it, and then present it. So if we start off with the same tool, we open up the P&IDs, and I'll use the P&ID that's the most complicated in terms of flow paths, which in my case is the TFF. So again, I think this has been shown previously in previous examples. I'm going to reset everything. So now suppose we have a project with a P&ID and the process engineers want to generate flow path to show to the automation group what needs to be done. Let's say this is going to be a simple one where we got product that's going to get transferred into the return take tank here, and then once it's filled in, we'll start the agitator. We'll stop the fill. We agitate for a few minutes, and then we recirculate bypassing the membrane. Then we transfer out there. So to start, we go to flow path menu. We create new flow path. Let's call it TFF example. So this just says that a file is created for flow path to be generated. I'll go slowly go through what can be done here. You can start saying, let's say initially we have a step that's basically product transferring. And then we call it, let's say, so within this, let's say we can create more row, insert new path right there. So for this, we can show detail. So over here, you can actually create notes to display as it goes through a path. So this is the XY location of the capture. You say we're going to do it here, and for phase step description, we'll put it somewhere here. Now we can say what you'll display is that product transfer in has a title step, and you can capture notes. Flow product into. Okay, so let's create a first flow path. We have product. We'll open this valve. So it goes in and the tank's being full. And then we just hit the capture flow path button. That's it. So you got, when it's captured, this text itself it will turn dark bold blue. Then we create new flow path. That's the agitator. Agitate step, begin agitation. Okay, so as you can see, when I go back to this path, it has that comment. When we agitate, after percent. So the second step is we turn on the agitator, and then we do a capture. So third step, we assume we finished transferring, which means let's create another flow path. Insert new flow path here. Transfer complete. Inlet line valves. Okay, so we could say flow into close flow path. Okay, so we start the agitator. We close the flow path. We can set it anywhere we want, really. So we close that. We close that. So, and we say that transfer complete, and we stop the flow, and we keep the agitator running. Capture. Okay, once it's captured, and we continue to agitate for, let's say, 10 minutes. Agitate, continue. Agitate product for X minutes. Okay, so we save it, capture. So you can see agitate product for X minutes. That's the, oh, I did this different. So this here, these are the comments. That's the phase. Actually, it's not phase. That's this, whatever you put in here. The next after that is down here. So what I can do is I can actually move that. So if I move this up to here, I'll do that later. So now the next step we want to show is that we're going to circulate. Create circular path, and then we start the motor. New flow path. Okay, and we could say okay, so what we can do here, we go through the pump, and we hit capture. And then after we say flow path, start pump. You could maybe have a better way of describing it. Start pump. So we create the flow pathway. Now we start the pump, which is this, and then we say start pump and run for minutes, right? And then we hit capture, and notice that this gets updated, but we can fix the location of this. I prefer the description to go under the title. We can change that. Um, yeah, it's tedious maybe, but we'll see. And after you circulate, you want to transfer out. And the way this is done is this is a single-use tubing. So normally it'll be closed. So to indicate that single-use tubing is connected, you double click on that so you can't see it, but it will then show once we transfer. So now I'm going to say stop pump and transfer out. Create new flow path. Maybe we use gravity transfer out. Bypass line. We're going to bypass the pump. So what's going to transfer out, what we're going to do is we're going to stop the pump. And let's see in here, product out to downstream vessel. Okay, so we stop the pump. We start going through the bypass. We close these, for example, and we go through here, through here, through there. So you notice that you'll automatically go to transfer out, but if you don't have the single-use connection enabled, you will not show that line. So transfer out. And then we capture until basically transfer complete, right, when there's no product in the tank. My description are probably not very good, but you can organize it in such a way that that's more useful. So basically, transfer is complete. Close valves. Stop. We stop the agitator. When it seems complete, you stop the agitator. Tank is empty, right? And then we say close the valves. Close. And then we close that. Okay, so now we're basically done. We can view our sequences right now. What's shown here are we configuring the flow path. Then when we click configure, we go view only. So how does it look like? We can see this flow path. It looks like this, right? And then we know it's transfer in. It agitates. That's the agitator. We know the transfer is complete, right? And then it says agitate certain amount of time. We circulate. We start the pump. Transfer out. And then we complete. So one of the thing, as I shown in the previous demo, where this can be useful, especially when we print it out, there's so many things going on. It's nice to see when you go from one state to the other what are the changes. So let's say we reset everything. and then we go like that, and we set this on. Show differences. So if you do that, and even when you print it out, it'll show it. So initially, these are the current valve and equipment states. We go to path 1. So from here, you can see this valve got changed, right? And then as you go along and agitate, if nothing else changed, it's hard to know that this step we got the agitator that got started. And then we see that these valves got closed, right? And then agitate continue, which means when you look at it, oh, it does nothing, but actually only the timer is incrementing at this step. Then we circulate and we see again the differences, which is very useful, especially when you have a very busy graphic and when you go from one flow path to the next. Without having this, it could be kind of difficult to know what happened from one to the other. So from here to here, the only thing that's different is you start the pump and then transfer out. We know we close these valves. See, these will stay at the same state. If we change it close, it will show, right? And then we hit the transfer out and then done. Now let's say as we were reviewing and then we find out, oh, wait a minute, when we're transferring out gravity drain, it would be nice to pressure the line. So how do we do that? So when we start the pump, between the pump and transfer out, we could insert a line, say pressurized tank. So we don't want to see this. We want to configure. We right click, insert new path, pressurize. Pressurize. Okay, so details, we want to show right, so to pressurize the tank, once we're here, what we'll do is we go through here, it goes through here, and we pressurize there. What this here is showing is that when the vessel is pressurized, these are openings. It means this line here is also pressurized. Well, there's pressure going all the way to here. So the reason this is done is during air blow, we may introduce pressurized air into the vessel, and we may, in the air blow, blow through here and drain. That was one of the criteria that was implemented for this TFF. So that's what that means. We pressurize it, and this line here is basically this being pressurized as indicated. So we pressurize that, and then we hit capture. So if we look at it, what we need to do is we inserted that, but in this step we don't have it. So yeah, what we need to do here to basically is to view only. So we go like this. We want to configure view details. Unfortunately, in this step, we maybe in the future you'll capture previous steps as well, which we could have done, but but for now what we will do is we show that this is going to look like this, and we open that. So we capture this again, and then let's see, we go to complete, and there's a button here, display flow path, rather than the other way. You can view it the same way here. So, and this is when it's complete. Oh, during complete, the tank needs to be empty. So you will do this, and we capture. Okay, and that's done. So as you can see, it's pretty easy. And then the modifications are made. We can actually go through part 1, product in, start agitator. And actually it's also good in the sense during discussion you can actually jump around, right? You can jump around from one to the other, and this is complete. And let's do an example of what happened. For example, you may want to print this out. So I think an example was done before, but let's quickly, as a final thing, print out this flow path. So we do this, print PDF. Yes, the entire flow sequence. So you have a choice of printing what you see currently or the entire flow path sequence. So I'm going to say yes. So this tells you, yep, it's okay. Sometimes you got a group of valves. So we're going to give it that name and save, replace it, yes. So there are actually 9 flow paths. It's generated. So let me open it up. Hold on. Okay, so now it's printed and we can actually send this out to somebody and they can actually view the various flow path. Right, so you got the description and you can scan down and so forth. Now currently, as you can see what I was saying before, that you don't know from one flow path to the next what equipment changed or what valve changed. So I'll quickly enable that feature and then show the resulting output. Hold on. Okay, so it printed it out. Sorry, I'll kind of pause it because I need to figure out how to best print it such that it shows the result I wanted. But nevertheless, what this is showing is like before, but the difference between before output and this output is I enabled show differences only. That hasn't, when you enable that and you print it out, it'll show you, for example, in the first frame, it basically started from default, which is nothing, and then you can see this valve here is bolded. So these are the two, and when you one step to the other, you notice of this flow path, you go to next, you start up the agitator, which is bolded, and from here, as stated before, nothing changed, but you're just allowing the agitator time. And from that frame to here, oh sorry, this is transfer complete, and you close the inlet valve. Sorry about that, but the agitator is running. This one is you keep the agitator running for X amount of time. From here to here, you open up these valves to set the flow path, and from here to here, the only difference is you start the pump. Nothing changed here, just agitating for X amount of time, and then you set up flow path by closing these valves, stopping this pump to allow transfer. You connect the single-use tubing, and then transfer complete. You stop the agitator, tank is empty, and you close these valves. So the way this works, should anything change or process change or modify, you don't have to restart all over again. You can basically update your flow path.